going to give everyone a few minutes to trickle in. And as everyone trickles in, I'd like to make a couple of announcements. We do have one of our virtual exam prep courses coming up starting in just a couple of weeks. It's a virtual prep course for the ISA Arborist exam. If you are already certified, I encourage you to let your coworkers and friends know that course is coming up virtually, so you can join from anywhere. It's over the course of 4 weeks and 7 sessions, about 2.5 to 3 hours each session, and it's a great way to prepare for the exam. We also have our Trees and Technology Day coming up at Decatur's Legacy Park. That's an in-person free event for members. So it's a great opportunity to learn about some new and emerging technologies and to network with your fellow arborists. So I hope you'll join us for the Trees and Technology Day. It is September 18th, and that again is in Decatur. We also have a work day coming up for our tree climbing championship. So I hope you'll come out and join us on October 3rd to help prepare the trees for our tree climbing championship. That's going to be at Stout Park in Cobb County. Lithia Springs is the city, or Powder Springs. So join us for October 3rd for our workday to prepare for our tree climbing championship that's going to be the weekend of November 14th, 15th, and 16th at Stout Park in Cobb County. Welcome, everyone. It looks like we've got people all the way from California to Augusta, Atlanta, Savannah. Thank you for joining us this afternoon. Just a couple of housekeeping. If you're here for the CEU opportunity, most of you are already aware of this. I will put a survey in the chat at the very end of the presentation. So if you'd like your one CEU for this webinar, make sure you stay to the end and fill out that survey. If you have questions as they come up, please put them in the Q&A. I'll be monitoring the Q&A and I will ask those questions as they come up. So feel free, if you have questions for our speaker today, to put those in the Q&A. We'll go ahead and get started as people are still trickling in. Welcome from Charlottesville, Virginia, Lawrenceville, Atlanta. Thank you all for joining us. Our speaker today is Pam Knox. Pam is the director of the University of Georgia Weather Network and agricultural climatologist in UGA Extension. We are so fortunate here in the state of Georgia to have so many excellent speakers, specifically from UGA. We've had a number recently, so we're really lucky to have that resource available to us for such a wonderful, knowledgeable base. Pam, I have known for several years as a member of the Athens-Clarke County Tree Council. Pam and I have served together. Pam has been the treasurer for a very long period of time. We've worked together several times, so I thought that Pam would be an excellent speaker for this presentation. So thank you for joining us today, Pam, and I'm going to turn it over to you now.
All right, don't forget to start recording.
Yes, it is recording now. Oh, that's a good point. Thank you for bringing that up. If you would like to go back and review any of the content today, I will email you at the end of the week with a link to the recording that you can find on our YouTube channel. Okay, now you can take it away.
All righty. Thank you, Jesse. It's good to be talking to you all. I think I may have talked to the group before at a meeting in Gainesville a few years ago, but always good to update you on the trends in Georgia and how they're going to affect forests and foresters. So let me jump right in. See if I can get this going here. There we go. Just a quick summary of what we're going to talk about. I'm going to just first talk about briefly about how we define climate, because people have different definitions depending on who they are. And then I'm going to talk about how it's changing over time. And I'm going to specifically look at Georgia, but of course we'll look at it in the larger context of the US and the world as well. Changes to the climate and how they're affecting forests is certainly something going to be of interest to this group. And then also just a little bit about how the changes in climate are going to affect outdoor work and other aspects of society too, because of course we don't live by ourselves in a cave, we live in a community, and all the community is affected by climate change as well. So first of all, if I would just sit down and talk to most of you, I think if I asked you what climate was, the number one answer I usually get is climate is the average weather. And that is true, but climate is a lot more than just that. So I've got here a couple of examples of different ways that you can define the climate. You can talk about how temperature and the atmosphere in general are changing over one place over time, or you can talk about it as how things are changing over a wider area. So you can see on the top graph there, and I use a lot of graphs in my talk, so if you're not used to looking at graphs, it may take a minute to digest those. shows the Georgia annual average temperature for each year starting in 1895 on the left side to 2024, the last complete year on the right side. There's lots of interesting things in this graph that we could talk about. The year-to-year variation is something that most farmers are very interested in because whatever happened last year is probably not going to happen again this year. But there's also these trends that probably the most notable trend for us is this increase in temperatures from about 1970 to the present. Again, there's year variation, but that's a definite rise. That's the same rise that's happening elsewhere in the entire United States, as well as in the world. And that's attributed to the increase in greenhouse gases that are building up in the atmosphere over time. 1970 is an important year for climatologists because there was a big change that year. That was the Clean Air Act was passed. And that Clean Air Act cleaned up the atmosphere. Before that, we had a lot of coal burning plants, a lot of particles that were being put into the atmosphere, and those particles kept the sunlight from hitting the ground. And things were actually getting cooler because the air was getting dirtier. So that was also a human-caused change of climate, just not the one that we usually think about. And I'll go into that more in just a minute because it does also apply to forestry and how forestry has changed over time in Georgia and the Southeast. Climate can also be defined by how it changes over an area. This is a county precipitation anomaly map on the bottom here. The greener it is, the wetter it is compared to the long-term average. And you got to keep in mind, this does not include August this year. And even if I did, June doesn't look a lot different than this, January through June. But at the beginning of August, we had this huge change in the weather this year. Athens got, in some places, more than 10 inches in just a few days. You'll see that in a minute on the city map for Athens. But climate can be defined not only by the average, but also the extremes, which also cause a lot more impacts than changes in the average do. Ranges of temperature, ranges of precipitation, average cycles over time. Of course, we have the annual average cycle of temperature getting the warmest in July and usually the coldest in January. And then the trends. We're going to talk about the trends today. So if we look in Athens, Georgia, which is where I happen to be, this is what we call a thermograph. Thermograph shows the average daily high and low temperature in that green band on the top. The red is the daily extreme high temperatures, and the blue, the extreme low temperatures. And then the gray on top of that is what's happened so far in 2025. And you can see we're clocking along in the early part of summer. Temperature is just a little bit above the long-term average every day, one of the signs of that increase in temperature. And then right at the beginning of the month, the bottom dropped out. We had several days where the temperature was down below 70 from a wedge of cold air that came down the east side of the Appalachian Mountains and came into Georgia from the northeast and dropped the temperature significantly and caused a huge amount of rain. You can see the rain on the bottom there just zoomed up. In just a few days, we had an increase of about 10 inches of rain in Athens. That wedge of cold air did make it through Atlanta. And even when I looked at the similar thermographs for places like Albany down in the Southwest, they had it too, although it wasn't quite as bad. So this is just a different way of describing the climate just compared to normal conditions. And you can go, and this one happens to be from the Peachtree City National Weather Service office, so they have the major cities. There are other places to get thermographs as well. If you want to know, you can email me. I think I contact information at the end, and I'll be glad to tell you how to get those. So here's just another view of the climate. We've got the timeline for temperature and precipitation. A lot of variation in precipitation from one year to the next, but not so much of a trend, as we'll talk about. And then also the drought severity, because drought affects a lot of forests in the state as well as what farmers are experiencing. And so all of those things are important. One thing I think that's interesting to note on the drought graph is that we've had more droughts in the past, but the ones that we've had lately are longer and they're more extreme. And we haven't had one of those in a while. And so I keep waiting for the next one to occur. Sooner or later it will, but we've had fairly mild conditions for really the last 10 years or so since the last big drought ended in 2013. We've had some smaller droughts since then. Temperature trends over time in Georgia, you can see trends always depend on where you pick your starting and ending points. Now, if you look at the whole trend from 1895 to the present, that's that dark blue line there. It's definitely increasing, but it didn't increase across Georgia the whole time. If you look just since 1970, when the Clean Air Act came into effect, it's a much more vertical line. It's a much stronger trend towards warmer temperatures. Sometimes people just pick times at random. There was one that was very popular with radio show announcers back starting with a trend in 1996 or so, 1998. We had an unusually warm year. They picked that for a starting point for the trend to show that there was no change in temperature over a time period of maybe 15 or so years. But that's really just an artificial lack of a trend because of where they picked their trend point. So anytime you see a trend map, you always need to look at where the starting and ending points are. I think one of the most interesting questions is, why did Georgia's temperature decrease during that time period from about 1920 to 25 to 1970? And there's really two reasons that we think it did. One is this increase in the number of particulates from coal burning plants, mostly in the Midwest, that were blowing into the Southeast. But also, there's quite a change in the land cover during that time. Early in the century, we had a lot more bare ground crops like cotton, and between droughts and the cotton weevil and the change of how people pick cotton, a lot of that was changed into forest. And now Georgia is somewhere between 65 and 70% forested. You can see the map on the right there. The areas that are green have increased in their forage coverage. The only places that really haven't are places like Atlanta, where you'd expect that, or Augusta, and then down there near Jacksonville and Brunswick in the southeast part of the state. So we're really, that period of cooler temperatures artificially gave Georgia a lower trend over the entire record over time. But since that time, we've seen this increase in temperature, which is just the same as we're seeing in other parts of the US as well as the world. Precipitation has been creeping up much more slowly. It's been very close to about 50 inches a year for most of the state, except for the mountains. Since that time, a lot of year-to-year variability, but there is a slow increase in that. Again, I think one of the interesting things here is that in more recent years, we've had multi-years where the precipitation has been below normal, and that's contributed to those droughts that we've seen. One of the things that annual total precipitation doesn't really capture is how the rain is falling. If you measure rain in terms of how many inches in a day, now here in Athens, we've had a couple days in the last week or so where we've had more than 2 inches in a day, and I got a rain gauge in my yard, so I keep track of that. The number of days with 2 inches or more, so that's a pretty heavy rain, big thunderstorm or something like that, or a whole day of significant rain, has increased by 27% over the last century. And so we know that we're getting more rain in these really heavy bursts than we used to. But the total annual rainfall hasn't gone up that much, so it means there's longer dry spells between those rain events too. That does some changes to the way water gets into the atmosphere or gets into the ground, because we cannot ingest all of that rain into the ground if it comes down in a really heavy way. That soil just can't take it in. Usually soil can only take about 1/10 of an inch an hour, just depending on the soil. Sand is a little better than that. And if you've got clay, of course, a little less than that. But a lot more of that runs off, so it's not really helping the groundwater very much. We look at how drought has changed over time. This is a different timeline on the top here. This starts in 2000 and goes to the present. Shows the percent of Georgia that's covered by drought. And there's different categories of drought depending on how severe it is. The darker the red, the more severe it is. And again, you can see those really 3 big drought periods in the early part of the 21st century. In fact, I came to Georgia in 2001, and I was hired because of drought here, because the state climatologist at the time was so busy answering the phone, he couldn't get any work done towards his tenure. So they hired me to answer the phones for him. I have been here ever since, although I have never picked up a Southern accent, as you can tell. So we've had these 3 bigger droughts and then a couple of smaller ones. The maps there just show the extent of those different droughts. I think the one that has gotten the most attention is the one from 2007 to 2009, because that was in North Georgia. And that's where Atlanta is, so that's where all the media is. And they were talking about Atlanta running out of water and having to truck water in to provide water for all those millions of people that were there. Fortunately, it didn't turn out to be quite as bad as that. The next drought in 2011 to 2013 Actually, it was worse for most of the state, but you can see it was mostly the southern part of the state that was affected. So it got less attention than the earlier drought did. But both of those caused a lot of problems for some locations. I think Griffin in particular doesn't have a really big reservoir and they had some problems with water, but we're able to get help for that. And then the very last drought that we had, the small one there at the end of 2023, just really covered the northern part of the state and it didn't really last for too long. So sooner or later, we're going to get another big one. I just don't know when that's going to be. If we look at how the U.S. climate is changing over time, in the left-hand map there, it shows the annual temperature. And the redder the graph is, that means the temperature is increasing faster. So you can see in a lot of the country, especially up in the western part of the country and the northern part of the country, the temperature is going up much faster than it is in the southeast. And that southeast is partly because we had that cooling period from 25 to 1970 or so. And that kind of washed out some of that temperature trend. But everywhere now, if we just did a temperature map like this for 1970 to the present, everywhere would be that darker red. Also see winter temperature is increasing more than summer temperature is. All the blue in the eastern part of the United States in summer probably is due to irrigation, because the irrigation keeps the temperature from going up as much. And if we have to stop irrigating at some point, the summer temperatures will go up faster as well. Precipitation on the right-hand side talks about greens as being increases in precipitation, just like we have here, only in many parts of the United States, it's increasing faster, especially up in the Northeast and in the central US. And you can see if we break it down by season, in the Southeast, really the only season that's getting wetter is the fall. Other seasons are getting drier. And so that is something that's really of interest. It doesn't mean we're going to run out of water. Overall, the Southeast is supposed to get plenty of rainfall. There's going to be more evaporation because it's going to be hotter. But it's definitely going to have more rainfall because we have two sources of water for rain right close to us, the Gulf down to the south and the Atlantic Ocean to the east. And both of those provide water vapor. That's what's really been feeding some of the rain we've had this year. We look at how the temperature is expected to change in the future. Everything I've talked about so far is just based on observations that have actually been made. So this is where we talk about how computers are used to help predict what the future climate is. You have to make a lot of assumptions about how people are going to behave, how much fuel is going to be used, if we're going to switch to more renewables, or if we're going to stay more with fossil fuels. And so it also depends on how far ahead you want to look. Right now, I think the one that's RCP 8.5 is the most extreme case. And I think almost all climatologists believe it's not going to get that bad because we are already doing things to change the amount of greenhouse gases we're putting into the atmosphere. But even if you look at the lower scenario case, RCP 4.5, see some temperature increases by mid-20th century. It's not that far off now. And then by late 20th century, of course, more extreme temperature increases. And temperature increases means that evaporation is going to increase as well. You see the biggest changes in the Arctic, and that's because they have to consider the effect of melting snow and ice. And as you melt that, what's left behind is the ground, and the ground is darker than the snow and ice are, so they warm up faster than we do down here, where we don't get snow very often, which is fine with me growing up in Michigan. I don't miss the snow too much. But so we expect to see differences around the world, but we're definitely going to see warming everywhere. Every single climate model, there's about 80 different ones, shows warming. It's not like we're going to avoid it. The warming is baked in by the physics. Sorry to say that. Precipitation is much trickier because precipitation depends on these small clouds a lot of times and whether or not they rain and where they're going to rain and so on. So projected rain change in precipitation depends a lot on which computer model you use. Most of them agree that good parts of the United States are going to get wetter, especially in the northern hemisphere in the winter because they're going to have warmer air overall that holds more water vapor. So they're more likely to see increases in precipitation in the winter. In the summer, we may still see some, but we're also going to have higher temperatures, which means evaporation is going to take a lot of that water. It's going to affect things like water supplies. If we have to use water, it's going to be harder to get access to it because there's going to be more people, but it's also going to have more pressure put on it in the future. Also, with those really heavy rains, the 2 inch or more rains, infrastructure and bridges are not built to handle that kind of heavier rain. So that's going to cause more problems for roadways. And so that is something that we're going to have to watch in the future as well. So if we ask for how else could climate change and this warming temperatures affect forests, we haven't really talked about extreme winds. I think you're going to have a workshop about that maybe later this week. Hurricanes are not necessarily going to increase that much in number. That's a question mark that we really have right now. But we do know that they're going to move more slowly. They're going to be more intense because they get their strength and their energy from the ocean temperatures. And the ocean temperatures are going up just like land temperatures are. So we expect in the future hurricanes are going to be stronger. They're going to develop quicker, and they're going to probably move more slowly. And as they move more slowly, it means that anywhere that gets hit is going to get hit with these strong winds for longer, and they're going to get a lot more rain. We have a rule of thumb that says 100 divided by the forward speed of a hurricane gives you an estimate for the amount of rain that you'll get in inches. The worst case scenario for Georgia was Tropical Storm Alberto in 1994, moving at 3 miles per hour. It was almost stalled over the southwest part of the state. 100 divided by 3 is 33 inches. And in fact, the record rainfall from that was in Americus at 27 inches in just a few days. Caused tremendous problems in Albany in the Flint River Valley there. Most other hurricanes don't move that slow. Michael moved at about 10 miles an hour. Places got about 10 inches of rain. That's going to be a problem, especially for coastal areas where the hurricanes are going to be the strongest because they're just coming in off the ocean. We don't really know what trends are going to be for ice and snowstorms. If you get warmer, you don't necessarily get less snow because you get a lot more moisture, so you could get more snow if the temperature is still below freezing or close to it. But we're probably, over the long run, we're going to see fewer and fewer of those. And humidity levels are rising with temperature. That can affect diseases of crops like fungal diseases. I'm sure it will also affect the health of trees because changes what's going on in the canopies and whether or not they can dry out. If we look at agriculture, some of the things we have to look at are things like the average climate conditions. So we have to know what kind of plants are going to grow. Certainly would be true of trees at all, and we'll talk about that in just a minute. Climate variability, most ecosystems depend on the climate to not be the same every year. Farmers like it because then they've got uniformity and they can plan ahead. But ecosystems depend on that variety of climates. And it'll be interesting to see how climate changing from one year to the next in a warmer climate is going to also vary. We don't really know that. Extremes of cold and heat can determine the length of the growing season. I'll show some examples of how that's changing in just a minute. Extreme heat, of course, if you have really high temperatures, especially if you've got a lot of humidity, you can have heat stress that affects livestock, plants, and outdoor workers, including foresters. And so that is something that has to be watched as well. We look at some of these changes and how they affect plant growth in general. The frost-free season length is increasing across the country, including Georgia here. Number of days of frost is decreasing. I don't know why they changed the color scheme here. You'd think that they would have put it different, but anyway, you can read the scale on there. Number of consecutive days of dry conditions is increasing slowly, and we talked about that earlier. And the change in the number of hot nights. Hot nights are really determined by how much humidity there is in the atmosphere. It's going to go way up. So it's going to be warmer in the mornings than it used to be. You're not going to have cool mornings before it gets hot in the afternoon. It's going to be hot all the time. So that is going to be an issue. I will say that the increase in carbon dioxide does increase plant growth a little bit. Sometimes some of the folks that are more skeptical of these warming temperatures will say carbon dioxide is a plant fertilizer. And that's true, it is. But unfortunately, the plants that like it best are things like poison ivy, which you don't necessarily want to see in your forest. And so that is not necessarily something that's good for the trees themselves. We look at things like plant hardiness zones. Plant hardiness zones you use more often when you're trying to pick plants for a garden, say. And they're based on the lowest temperature that somewhere gets each over the course of time. So the colder it is, the lower your plant hardiness zone is going to be. And you can see since 2012, they have had a change in the plant hardiness zone that's amounted to about 1/2 category. So now in Georgia, the very northeastern part of Georgia, it's mostly in band 7. hard to read that. You have to go into the website and read it more carefully. And then as we go farther south, we get towards more and more tropical areas. By the end of the century, that's going to increase, and half of Georgia is going to be in zone 9, which is not quite tropical, but certainly close to it. So those zones are going to continue to increase. And what that means is if you're going to put plants in your garden and you want it to be around for a long time, perennial plants, you're going to probably be planting things that can handle more heat in the future. The same thing is true with trees. If you look at the length of the growing season, it's changing more in the west than it is in the east, but both areas, the growing season is increasing over time. That means that the last frost in spring is a little earlier than it used to be, and the first frost in fall is a little bit later than it used to be. The time period between those is the growing season. And so we can see that. And in fact, if you look at the map here that shows the dates of the average date of spring frost, you can see that's getting earlier, and the last date of, or the first date of fall frost is getting later. And so that means we have more time period for the trees to be putting out leaves and growing, and all the plants that are underneath the trees as well, following the same pattern. Important for things like fruit trees. If you would have an orchard, for example, and you're worried about the trees blooming too early and then getting hit by a late frost, we are seeing some of that now because we have these warmer winters, but the trees get enough chill hours if they're fruit trees so that they are blooming earlier than usual. And then we can still get a frost after that, and that could just really destroy the fruit crop for that year. We had that happen a couple of years ago in 2023 with the peaches. Really lost like 90% of peaches across the state because we had cold early in the winter, and we had a warm winter in January. The trees had enough chill hours. They got ready to bloom when we had the first warm spell. Then we had a frost, which was not a late frost, but it was late compared to where the trees were in their life cycle, and just really killed off most of the flowers for that. So if you worry about blooming trees, fruit trees especially, that's something that you really have to watch. We look at how it's changing forests. This is a map that shows the increase in the number of weeks with very large fires. I forgot to look to see exactly how they define that, but I would assume it would be just not the local ones of just an acre, but it's the ones that cover much more area. You can see that there's 2 areas in Georgia that are more susceptible to increases in large fires. One, of course, is the coastal plain, a lot of pines there, and that is likely to see that. Some of the other droughts that we've had earlier in the century have started down near Waycross. There's a lot of trees and there's not necessarily a whole lot else. And so if we do get a drought, that can be one of the areas either started by some sort of careless human or by lightning. We don't have as much in the way of really bad fires here in Georgia, although I can remember with the 2016 drought, which really hit northwest Georgia and then into the Smoky Mountains, how much smoke was coming off the fires up in the Smoky Mountains. I walked out of my office in Athens, and you could just smell there was a campfire a mile away because that was creating a lot of really big forest fires. You can see the Appalachians there is a secondary place where we do expect to see more increases in big forest fires in the future, something that has to be prepared for. Obviously not going to be as bad as out west where they've got much drier climate to begin with and a lot more trees as well. Yeah, I see William Haas talked about the debris down south. After Michael, we had a lot of tree debris. Of course, now with Debbie was more of a rainstorm than a windstorm, but Helene for sure knocked down a lot of trees. And all those trees are sitting on the ground because a lot of them, very hard to harvest them. And plus the cost of lumber went way down because there were so many trees available. And so a lot of that's still just sitting there now. Some areas may switch from forest to savannas. I've got a map to show that in just a minute. Coastal forests may also die because sea levels are going up. Since about 2010, sea levels along most of Georgia coast have gone up by 6 to 8 inches. And so as that salt water goes up, then the coastal areas that are next to it the groundwater becomes more and more salty, and it kills off some of the forests that are right along the coast. Here's a map that shows how climate change is affecting the makeup of natural forests. the recent past, you can see on the left-hand side there, a lot of Georgia has pines. That is pine. That was a cooler period than it even is now. But you can see the dark blue and the lighter blue are mostly pine forests. And if we look at the projection for 2070 to 2100, there's a lot less pine in there now. There's a lot more deciduous forest. And so that's going to change what you can do with those forests, what's going to grow there effectively. That doesn't mean that there's not going to be pine plantations, but they're going to be more stressed and they're going to have to be more careful about where they get those seedlings in the future. So some of the changes to the forest that we expect to be made, red spruce and hemlock are already declining. They're probably going to be gone from the natural forest. Pine growth conditions are going to deteriorate. It's probably a lot of the production may move farther to the north, or it may change to longleaf pine. And I will admit, I am not a tree expert, so some of you probably can answer these questions better than I can. The water demand from urban populations is going to compete with more drought and increased slower stream flows in some areas. The streams are going to be more flashy. We're going to get these big floods that are going to go through, and then in between, they're going to be much lower than in the past. That will affect, though, the groundwater levels and the ability of the forest to find enough water to sustain themselves. Warmer temperatures are going to probably increase the way soil or organic matter in the soil decomposes, and that may also change some things for how the plants are able to thrive or not. We'll also see more increased fire hazards and probably more insect outbreaks because, of course, at the same time that the climate's changing, we're also getting a lot more invasive species. And those invasive species really take advantage of these warmer conditions to grow rapidly. As I looked outside my window this morning, I saw all these Joro spiders, which, of course, have come to the United States now. They're not very bad for the ecosystems compared to a lot of other invasive species, but it's just a sign that they're coming, and we're going to see more and more of that in the future. Other kinds of changes that we're likely to see. On the left-hand side there is a projection map of Atlanta. If you look carefully, you can see the county outlines for Atlanta there. And the change, even over 20 years, in how much of that is urbanized. Some of us work really hard to make sure that our cities have a lot of trees in them. And I suspect most of you are involved with that, which is great. Of course, that's where I met Jesse from the Tree Council here in Athens. And trying to keep trees in the urban population is really important. There's a lot of different reasons for that. One, of course, shade keeps things cooler. It just provides a nicer environment and provides oxygen to the community in some respects. But it's going to be harder to do because there's going to be more competition in the future, and it's going to be hotter. So the kind of trees you can plant is going to be interesting. Also, with more urbanization and pavement, you got to figure out how are those trees going to be watered? Where are they going to get that water from? And even when we put trees in Athens now, we have to think about, we can't plant them in just these little tiny holes because they're not going to get enough water. And so you have to think about that as well. There's also all these competing demands for land. It's the urban people are trying to expand the cities because they need housing for all the population that's increasing. You've got farmers that want to plant more plants because they need to increase their income or at least keep from going out of business for sure. And then we have people that want to plant more trees as well. And all that has to be taken into account in the number of people that are definitely increasing in Georgia, especially here in North Georgia. South Georgia is actually, populations are going down. They're becoming less desirable for people to live in. Let's see, there's a couple questions here in the chat. Let me go back to those before I talk about the other changes here. Let's see. Dave Long asked about the shift to less pines due to mesification and lack of fire. That's probably a contributing factor. The plantation pines, they don't want fires to go through because then they're losing income. So I suspect methods in the way we do planned burns or whether or not we have any burns at all is something that's going to affect the plant diversification in those forests. So that may be interesting. I think that map that I showed is basically based just on the climate changes. It's not including changes in how we manage the land. And Josh asked about combating coastal creep by planting saline tolerant trees. I think that's definitely a way that's going to have to be done for any of these things. We need to be able to pick plants that are going to really live and thrive over the long periods. When you think about it in the past, foresters have a longer term view than most other people do. Farmers are more interested in what's happening in the next year or maybe the next 5 years. The foresters have to look 30 or 40 years down the road. If you're going to put a tree in the ground, you want to make sure that it's going to still be in good condition when during its whole lifetime. And then if you're planting it to harvest it eventually, then you want to make sure it's going to still be in good condition when it's ready to harvest, whether if you're harvesting over 20 years or over 40 years or whatever. That means you're going to probably have to pick plants that are coming from different locations. Now you may have to pick pine seedlings that come from South Georgia or maybe even Florida to be ready for the warmer climate in the future and be more accessible for that. So some of the other changes that I think we're going to see more extreme weather. That's going to cause changes in floodplains and stream ecology. So it's not just a forest issue, but it's a whole ecology issue as well. Species are going to migrate. If you follow birds or if you're just interested in the different kind of species that there are, they're going to migrate wherever the plants are that they find to be the most useful to them, whether it's for eating or shelter or anything like that. So that's going to change over time. Then it will be species of animals, but it will also be species of plants that are going to move. Other extreme changes could change landscapes from forest to savanna. So maybe we'll have less trees overall because we just won't have enough water to support really dense forests. I don't think we're going to see any deserts in Georgia anytime soon, but other parts of the country certainly could see that shift. And some ecosystems at higher elevation could disappear. This is again a problem that's more something for the western part of the United States. But even in Georgia, we have higher elevations in the Northeast. And so they're going to see some changes. I suspect that we may see the end of apple production in Georgia unless we can find varieties that can handle warmer winters than they do now. So that's something that's possible to change, although farmers are very innovative and foresters are very innovative about creating or finding new species or new varieties that they could use to respond to the different climates that we're going to see in the future. We could see more frequent extreme events. Here's an example that I talked about earlier of Hurricane Michael. It came across Georgia in 2016 in October. Tremendous losses for not only cultivated crops like cotton, pecans, but also to timber. A lot of the area in the panhandle of Florida, people had put in timber lots that could serve basically as their retirement, and those were completely wiped out. There was so much, and of course, some of the sawmills were also damaged, that a lot of it just sat there and dried out and then became a source of combustible fuel for fires. And they had some problems with fires down there as well. So we saw that again, not so much with Debbie, but last year with Helene. Most of the attention in Helene, I think, went to Western North Carolina, as it rightly should, but we had a lot of losses to timber in Georgia as well that were documented by the state. So that certainly caused problems. My weather stations, I think the highest ones measured a wind of about close to 100 miles an hour for the peak gusts down near Valdosta, but other places had significant hits too. I know that the UGA research farm in Midville lost almost their entire pecan grove because of the winds from Helene. And that's really a problem as well. So let me catch up on the chat here. Let's see. Mateo talks about increased drought stress and the increase in southern pine beetle pressure. Absolutely. If we're going to have more droughts in the future, we're definitely going to see more problems with the southern pine beetle. We're going to see problems with other, I think, invasive species as well. And then Darlene talked about if the projections start to happen, then there's also going to be a shift in the economics of forest products for many states. Yeah, absolutely. One of the nice things about looking at forests is that there's a lot of benefits to forests other than aesthetics or other than putting out carbon dioxide or keeping things cooler. But there's also a lot of products in Georgia that come from timber sales. And, that's going to change as well because the kind of trees that we can grow and their market value is going to probably change. Whether or not we have enough facilities to handle those and whether they might be affected by some of these extreme weather events. One of the problems with Michael was that not only did it cause a lot of problems for farmers, but it also destroyed almost all the places where they can sell peanuts. So a lot of them had peanuts and they had nowhere to put them or to sell them, so they had to store them somehow or ship them out of state, which of course is more expensive. And so all of those things have longer term consequences. And Darlene is right that it's not just the trees themselves, but it's what you do with the trees that also have to be considered in this.
Hey, Pam, I just want to make sure you see the Q&A question as well.
Yeah, I'm not seeing the Q&A. I'm only seeing the chat. So if you've got some Q&A questions, please jump right
We
in.
just have two so far. Why don't we want poison ivy in our forests is the first question.
Oh, I guess it does have some value to it. Most people think of it as a nuisance plant, but it is a natural plant. So I guess it does provide some cover, it provides berries. And so I think most people probably wouldn't want more, but I think that's my own personal opinion more than anything else. I think poison ivy certainly has a place in our ecosystems, and it's probably better to have that natural occurrence than kudzu, which is more introduced.
Do you think we'll also see more tree death from fungal diseases like oak wilt and Dutch elm disease?
Yeah, I think probably so, because as the humidity goes up, I think we're going to see, I know in agriculture at least, when we have more humidity, fungal disease pressure goes up a lot. And so I would expect that to be true. Partly depends on what the wind speed does, because if we have higher winds, then we could get enough ventilation to keep the plants from really developing a lot of fungal diseases. Unfortunately, most people think the wind speeds are probably going to die down somewhat. So that might mean that the humidity sticks closer to the plants, and that would be more likely to cause problems. But I think it would really depend on the particular disease. But I would say just overall, my sense is that with higher humidities, we're going to see more fungal diseases, and that's going to be more of an issue. Okay, Mateo says the birds like poison ivy, so there's one good point. Okay, any other questions? Otherwise, I'll finish up here. I'm almost to the end. Not all the changes, as I said, would be bad. The increased carbon dioxide will fertilize plants. Unfortunately, it's a secondary effect. Some plants grow faster than others do from that, but it does have some positive effect. Another thing to keep in mind is the Southeast is not going to be affected nearly as badly as some other parts of the country are. And so production of things like vegetables is probably going to move out of California because they won't have enough water. That'll put more production into places like the Southeast that have more water. That's just another way of competing, right? Because it's either as forests or as farms, unless you have a way to figure out how to grow both. We're still going to have timber, so we can still provide wood products to the rest of the country. Of course, they will out west as well. The population growth is going to increase demand for lumber and other wood products, like that could be a benefit to the Southeast. And of course, planting trees has good effects on sequestering carbon. Also, you can use wood products like wood pellets as an alternate source of energy. They're doing a lot of that now. They're shipping a lot of wood pellets to Europe, other parts of the world where they're looking for more ecologically interesting places or interesting ways to get more energy production than just burning fossil fuels. So this is an example that they used to have a decision support tool called BindMap that would tell you where to go to get your seedlings if you want to get seedlings to match the future climate. Unfortunately, they took it down in October, so it's no longer there. There is a website here where they have similar kinds of products where you can say, if I have to match the climate of 30 years from now, then where should I get my seedlings from? So if you go to the PineMap website that's here, the decision support tool is no longer there because it's just too far in the past now. But it is an interesting way to think about where you might have to get your seedlings in the future. And then another thing we haven't really talked about yet is the effect of this heat on outdoor workers' health and safety. The thing is, if it gets a lot hotter, then we're going to have more hot days and hot nights. And people are going to be out working in those really hot conditions because you cannot do forestry from your office chair, at least not most people. And so you have to be out in it. You have to be especially aware of how that heat is going to affect you. And in agriculture, they're starting to do more overnight work. I don't think it's really very safe for forestry, but if you're on the ground, maybe it's okay because it's cooler at night, although it's also more humid. But you need to make sure that your workers understand how to identify heat illnesses and drink enough water and take enough breaks so that they're maintaining their own safety. This could be true for any outdoor worker, whether it's agriculture or forestry or somebody who's working in construction doing road construction. All of those really have to be educated about what heat diseases are and how to prevent them. And of course, the management has to keep that in mind too and make sure that they're not overworking their folks as well. Let's see. There we go. So, just a reminder that we are all part of the global community. We need to work to help keep climate change from getting worse by reducing greenhouse gas emissions and so on. I will probably irritate some people by saying we ought to use less gas-powered equipment, use more battery-powered equipment, because of all the things that put off a lot of carbon dioxide, it's small engines. And small engines, whether it's lawnmowers that people use in their own homes or chainsaws or anything else, they're very effective, but the small engines put off a lot of carbon dioxide because of the use of fossil fuels. Yeah, two-stroke is much worse than four-stroke. That's true, Mateo. But even by changing the equipment that you use, that can help. Worrying about things like transportation can be important. You can see on the pie graph here on the right-hand side, agriculture and forestry contribute a quarter of all the greenhouse gases to the environment. This is, I think, a world statistic. So we're not going to be able to change all that. Of course, we need to eat, we need to build houses to live in, and so on, but we need to do it thoughtfully. And that's just something to keep in mind. By doing that, we can keep things cooler. We plant more trees, keep things cooler. We need less air conditioning, and so we need less energy to do that. And of course, protecting natural land and trees so that we can absorb carbon dioxide and keep the temperatures lower is a really good thing to do. And foresters are really helping to make that happen. So here's the bottom line. The next century, the temperatures are probably going to rise 5 to 10 degrees Fahrenheit across the United States. Big difference between 5 and 10, but we don't know what it's going to be because it depends on people's behavior. And if you think it's hard to predict the weather, you should try predicting human behavior. Growing season will probably increase by about a week for every 1 degree Fahrenheit. So you can imagine if we have a 10-degree change in Fahrenheit, we're going to have much longer growing seasons than we do now. Precipitation could increase or decrease, but certainly evaporation is going to increase. And more rain is going to run off, so that is going to cause changes, probably decreases in soil moisture. Winter storms should be less frequent. Tree species are going to start changing over time, and we may be able to grow more tropical kinds of species in the Southeast in the future. More competition from both agriculture and cities, but we're still going to have seasons and variability from year to year. So Mark says we need to stop clear cutting across land. I agree with that. Leave some older trees is also definitely a good idea. And Juliet is stop diverting water to data center cooling. I totally agree with that, but everybody's got to have their data centers. And so that's another competition that we're going to have to deal with in the future. So there's some of these websites, unfortunately, I think have gone away since January. There's usually other places to find them on older websites, so you can check that out. And then here's just my contact information if you're interested in contacting me. There's my email on there, or you can call me. My weather network we're now up to 91 stations across the state. And they're in a lot of areas, not in Atlanta, because our Atlanta station was on top of a building and it was not useful for agriculture. So we finally took that one out. Don't have too much in the southeast either, although we did put one new station down to the southeast of Valdosta. So I appreciate all your questions and all your time. And I'm going to stick around for a few minutes in case there's any more questions or comments. We still, I think, have a few minutes left.
Thank you, Pam. We do have a few minutes for questions. So if you have questions, please feel free to drop those in the Q&A. I will mention that we do have another webinar scheduled for September with Dr. McCarthy, who spoke last year on emerging pest concerns in trees. She'll be speaking again on the same topic for this year next month. I don't have that quite set up in our system yet, but that will be next month's webinar, which I think ties in very nicely with this talk. Make sure you pay attention to our events page and sign up for that about emerging pests coming up next month. That will be at our other webinar time in the evening. It'll be at 6:30 p.m. and I believe it will be September 16th. So stay tuned. That will be available soon. Looks like there's some chatter in the chat. I don't know if we have any questions here. Let me look. Looks like mostly just comments. So if you do have questions, put those in the Q&A. I will put the survey in the chat. I'm going to go ahead and do that now. So don't put your questions in the chat because then you'll lose track of the survey. So give me just a second to do that.
Yeah. And Darlene, you're right about the double cropping. There's a lot more double cropping that's going on. There's also changes to new kind of crops. Like in Georgia now, they're growing citrus and olive trees, which they didn't used to grow in Georgia. But it turns out that the climate down in South Georgia is really conducive to growing both of those tree fruits. And so that's something that people are looking at in agriculture as far as changes in the future. Michael, I don't know anything about soil amendment moisture surfactants, but I imagine there is some research. I just don't know it.
We did have a question in the Q&A. Will rising temps be more related to longer warm seasons or hotter days?
I think longer seasons. The hotter days, most of the increase in temperatures we're seeing now is nighttime temperatures, not daytime temperatures. Daytime temperatures have some natural cooling impacts, like we have more water vapor and we have warmer temperatures, we tend to get more clouds, and that keeps things a little cooler than we would otherwise. But nighttime temperatures are really defined by how much humidity there is in the atmosphere. As the humidity goes up, we're not going to cool off as much at night. So if you break the trends in temperature down, the daytime is warming up at only half the rate that it is at night. And I think that's going to be probably as much of an issue as anything.
All right, I will stick around for just a few minutes so that in case anybody needs that survey, they'll have the link in the chat. But thank you so much, Pam, for your time. I really appreciate you sharing your expertise with us.
You're welcome.
I look for that video in our YouTube. I'll send out an email with the link to that in case you would like to review the content from today. And we'll see you all next month at the evening webinar with Dr. McCarthy. So thank you, Pam. We appreciate you.
Yeah, thank you for the invitation. I really enjoyed it.
Have a great afternoon, everyone.